Okay, YouTubers, this is Joe from ArtAlienTV. Now today, I've got some incredible images from the James Webb Space Telescope to show you. I've got all the latest ones, not just the first one that like a lot of videos have shown. What I did, I thought I'd wait until there's a whole set of these to show, and then I can give you all the links so you can check these out yourself. This is a participation kind of video. I'm not going to spend too long showing you each individual image, because it's very hard to get across how good these really are. And there's too much for me to actually show you. So what I'm going to do is just give you a quick look at each one and what to look for. And I'm going to provide you with all the links so you can come to my Gigamacro site here. And I've got the main 5 here at the top. So if you follow the links in the description, near the top of the description, below the video, you'll see links to all these, and I've also got here some other articles for you to check out as well as the actual page here, which is the Webb Space Telescope homepage or gallery. This is, so you can follow this link and actually download these yourself. Some of them are quite large, some of them aren't so large. They're sort of 150 megabytes, 170 megabytes, that kind of size, but you can download smaller ones if you wish. But what I've done here mainly is I've uploaded them, I've enlarged them ×3, so that when you zoom in there's no pixelation, or very, very little pixelation, which means you can literally look at the image. I mean, this is over a gigapixel, okay, it's 1.11 gigapixels. That's big, right? That's really big. The original was a third of that size, but doing this means you can actually zoom right into this stuff and get right in close, and there's no pixelation. It just holds the detail really well, and it's quite stunning. The actual detail in these images is incredible. It's the best we've ever had, I would say, and a lot of people are saying that online. A lot of people from NASA and astronomers from all over the world are absolutely going crazy about these images because they are really quite spectacular. It's quite hard for me to explain how good these really are. So what I've done here, I mean, this is, in my opinion, the best one. I mean, the colour in this is absolutely spectacular. This is an infrared image, near infrared. It's got all the information here on the side. Okay, it's got all the information about the image here, so you can read this. You can also link to the original images up here from this NASA link at the top. Like with all my Gigapans, you can link to the originals. So this is all kosher. I haven't messed with these apart from enlarging them and uploading them, okay? I haven't touched the color or the brightness or anything on these. These are spectacularly good as they are. No need to enhance these, guys. I mean, there's nothing wrong with taking clips and enhancing them, but the actual quality, the color quality and the depth of field we have here is spectacular. Absolutely spectacular. So I've got this up here as well. Now, this was the first one that was taken. I'll show you this in a bit more detail in a minute. But just to give you an idea, because most of you would have seen this online, you may have seen it on Facebook or on Twitter or whatever. And quite a few channels have shown this on the YouTube. But this gives you an idea of context of how much this is zoomed in. Now, this is the first image that was taken, okay? This is Webb's first deep field image. First deep field, that's what it's called, right? And this isn't huge, this one. It's quite big, 189 megapixels. Yeah, so it was reasonable size to start with, and I enlarged it, obviously, but you can actually see gravitational lensing here. Now, if you look around this area here, near the middle, we've got this close star in the middle. I don't know which one that is, but it's one of our close stars in our galaxy. And then we have a distant galaxy here, which has been stretched. Okay, just here. This is a galaxy, but because of gravitational lensing, it caused like a fishbowl type effect, and it stretches things in the distance. Now, so basically, this galaxy here is acting like a lens, and is distorting the distant galaxies that are behind. And it kind of it magnifies them, but it also stretches them like this. So in reality, this would be like a sort of oval shape like this, and it's been stretched by gravitational lensing. There is a page up here which I've got for you to read from Earth Sky. What is gravitational lensing? And it goes into detail about how this actually happens and how it works, how the light is bent by the gravitational effect of the galaxy here. And we have a sort of quasar or a bright object behind, and that could be a quasar, it could be a bunch of stars or a galaxy or whatever. And then the light is bent and then kind of curves round and it kind of distorts it before we get to see it. So it explains it pretty well here. I'm not going to go into great detail about that. You can check out the links below. This will be in the list of links below, so you can check this out and read it, or you can just look it up. I mean, there are loads and loads of articles on gravitational lensing you can just check out. And I've got some other pages here as well. But this one was spectacular. This is the first one. And there are some crazy details in here. And it really is quite spectacular to look at. I mean, just looking at the star itself, the spikes on this is quite amazing, and sharp, detailed, and wonderful colour. Okay, really insane. This is taken in near infrared, which means these aren't the true colours. They've been somewhat exaggerated to bring them out more, so we can see further. Okay, just to give you an idea how far away some of this stuff is. This is a tiny, tiny window or segment or section of the night sky, or the universe, I should say. Now here, I've got that image here. It's been rotated to fit the background, and this just gives you an idea of how much this telescope has zoomed in. Now this is that image I just showed you, and I'm going to zoom out, and this is it in context with the rest of the universe. Okay, it's a tiny, tiny snapshot right in the middle there where my cursor is, and as we zoom out, it just disappears. That's so far, right? That gives you an idea. This is the edge of the Milky Way, I think, here. Just this bright section here. Okay, so that gives you an idea of how much this telescope has actually zoomed in. It's absolutely incredible. So there we are. Now, if I zoom in now, oh, there it is. I managed to keep it in the center. Okay, so that gives you an idea of how far this thing has zoomed in. Absolutely insane. So there'll be links to all these things. There's another kind of widget thing here that someone's uploaded. One of the guys from, one of the astronomers that I follow on Twitter has put this up, called John Christensen. This is really cool. And what he's done here, he's got the new JWST images, like this one, and he's put the Hubble images next to it, like this, so you can compare the difference in quality. Okay, there's the Hubble image, which is nice, and then here's the new one taken by the new telescope, the JWST, or as some people have called it on Twitter, the Jelescope, which I think is great. I think it's one of the NASA people, one of their kids has come up with that or something, so I quite like that because it's a lot easier to say than JWST or James Webb Space Telescope constantly. So there's the Jelescope image there, and there's the Hubble one, and there's another one down here. This is really cool. There's the Jelescope, and there, for comparison, is the Hubble. Okay, now the Hubble ones are good, and I've been looking at Hubble images for many, many years, as I'm sure a lot of you have, and they're great. But they don't have this level of detail. They have nowhere near the sharpness and definition that these do. These are not only brighter and more detailed, but they're just incredible. I mean, it's hard to get across how good these really are. Okay, so let's have a look at this one as well. I'm not going to go through all of these, but this one was spectacular. It's not as big as some of them, but it's got some wonderful detail in it. This is a dying star with a huge cloud of sort of gas and matter around it. Okay, and when you zoom in, you can actually see the sort of strobing effect you get from the star in the middle here. Absolutely incredible. The detail is spectacular, and the colours are absolutely wonderful. But these are not normal colours, as it says in the description here. This is also near infrared. Okay, so in reality, it would be a lot darker, and you wouldn't see a lot of this as much. You would see the central area, but you wouldn't see a lot of this around here. Okay, but that's the whole point of this telescope. The idea is to show things that we haven't seen in such great detail before. Things are a lot further away, but we're seeing them in much sharper definition and brighter colour. So we can really see the textures and the gases and the galaxies and the stars in real detail. And people are going to be looking at these for years to come, these images. And there will be a lot more, of course. And this one is my favourite. This is absolutely spectacular. Just the colour and the sharpness of this stuff. I mean, if you can just pick an area and zoom into a star and look at the stars. I mean, they look incredible. But this nebula here, the Carina Nebula here, is quite spectacular. It's quite incredible. The amount of detail we're getting in here when you zoom in. And because I've enlarged this ×3, you can zoom right in and it doesn't pixelate until you get right in like this. You just about start to see it pixelating, which is why in enlargement, when I do Mars images, I tend to do them ×2, because if you over enlarge ground images, then they go a bit kind of fuzzy. They go a bit fuzzy and you lose definition. But with these, they don't. You can just enlarge them because they were taken at 300 pixels per inch, which is great. Okay, so they're already really good anyway. I've just made them bigger so we can zoom in right up close and look at some of these things really closely without really losing any detail. Okay, so I mean, look at this. When you zoom into that, it's quite spectacular. So I'm not going to go through every little bit of these images. I will put some clips of these in a minute at the end of the video, like I always do. But I do recommend that you follow the links below and come and look at these gigapans on this site here, because they are spectacular and you will not regret it, I promise you. And I've got all of them so far, and I will be adding more as more come in. And you can check out more details about the actual images on here as well. This gives you a scale as well, and this is mind-blowing. That there is 2 light years from there to there, which is absolutely incredible. So when you look at this image, this section here is 2 light years across, okay? Because it says here, from that, almost from the just to the right of that bright star to there. Okay, so that's from here to here is 2 light years. So this is covering a very, very large area indeed, okay? And it's absolutely mind-boggling when you think about it. It really is. Some wonderful details in here. The Quintet, Stephan's Quintet. Okay, look at the interesting formations of stars here. Absolutely incredible. It really makes you appreciate how small this planet is when you look at things like this. What we're doing here is we're looking into the distant past, and some of these galaxies are right on the edge of the known universe, okay? We're looking over 14 billion years into the past. It's taken millions of light years for a lot of this light to get to us. So we're looking at stuff as it was, not as it is, okay? This is like a time machine looking at these images. And when you think about that, it's quite mind-blowing actually. There's loads of diagrams and explanations about how all this works and how it was done, and why these things look like they do, and how old some of these things may be, okay? So thanks for watching, everybody. Check out the images coming up in a second. Please like and subscribe if you haven't already. I will be doing another video in a few days' time, probably a Mars or Moon video, who knows? We will see what happens. If there are more images from this telescope which are as spectacular as these, I may do another one on this. So thanks for watching. Check out those links below, okay? I'll see you soon.